Okay, before we look at one more tangent line problem, I want you to take a second and write down the steps for finding the equation of the tangent line to a curve at a given x value. I want you to write them down, and I don't want you to look back at your notes unless you absolutely have to, but I want you to write down the steps it would take to find the equation of a tangent line to a curve at a given x value. So pause the video for a second, and then when you come back, I'll have my answer uncovered. So we start by finding the derivative, f prime of x, because the derivative is going to give us the slope of the tangent line. Then we're going to plug our x value into our derivative, because that gives us the slope of the tangent line. Then if they just gave us the x value, we have to plug x into the original f of x to find our y value, and then plug into our point slope formula, y minus y1 equals m times x minus x1. Now, technically, you could have step 3 at the very beginning. It doesn't matter when you find the y value, but just so you have these general steps, that's what I'm looking for, okay? I also want you to do this right here. Find the equations of the tangent and normal lines to this curve at x equals -1. Okay, so take a second, work on that, pause the video, work on it, come back for the answer. So if we've got to find the equations of the tangent normal lines, we've got to start with the derivative, because that's going to give us the slopes. So the derivative is -6x squared minus 4. So when we plug in -1 into that, we get a slope of -10. And apparently I calculated the y value as well, plugging in -1 into the function, and got a y value of 8. So that's where I get the point slope formula there. And then the normal line has the opposite reciprocal slope. So it's the exact same equation, except it's got the opposite reciprocal slope of 1/10. Okay, here's one more tangent line problem that I've seen them ask before. We need to find the equation of the line or lines that's tangent to the graph of f. So when we see tangent to the graph, we should be thinking derivative, okay, and parallel to the given line. So anytime we've been asked to write a tangent line, we've been given an x value. But they didn't give us an x value here. We're told that it's parallel to this line. So we're going to have to kind of twist our thinking just a little bit. So how about we start with the derivative, because that's where we always start. F prime of x is equal to 3x squared. Okay, so that's the derivative, 3x squared. But we don't have an x value to plug in. But they tell us that it's parallel to this given line. What do we know is true about parallel lines? What was our point in finding the derivative of f? The derivative always leads us to the slope. Parallel lines have the same slope. So what's the slope of this line? It's 3. So I don't know the x value, but I do know the slope. So the slope is 3. The slope is the derivative. F prime of x is the slope. The slope is 3. So if I set my derivative equal to the slope, I should be able to find out where it has that slope. So let's solve for x. Divide by 3. 1 equals x squared. Take the square root. What do we have to remember always when we take a square root? Gotta remember the plus or minus. And guess what? The fact that they said lines, possibly, I mean, it doesn't guarantee that you're going to have more than one, but you should probably be thinking in the back of your mind, maybe I'm going to have more than one of these. Okay? So we just found out where the tangent line is parallel to that line. So now we can proceed with writing the equation of our tangent line. So we have the slope. The slope is 3. We have the x. What do we need? We need the y. So f of 1 is equal to 1 cubed plus 2. So that's what, 3? And f of -1 is -1 cubed plus 2. Be careful with this. -1 cubed is -1. -1 plus 2 is 1. So here are the equations of our tangent lines. Y minus 3 is equal to the slope, 3. times x minus 1, and y minus 1 is equal to the slope of 3 times x plus 1. So it's just a different way of thinking. We're still writing the equation of a tangent line. We still need the slope and a point. But when they tell us we're parallel to another line, they're giving us the slope. They are giving us the slope. What we have to use the derivative for is to find out where. Where does it have that slope? So we set the derivative equal to the slope to find out where. And then we got to plug the where into the function to get the y. Okay, so I've got a couple of problems. We got to go back to page 131 to practice this skill right here.